Okay, let's finish off 1.6. The last thing that we had in 1.6, we'll say 1.6 continued, was what we call even and odd functions. Okay, let me change this pen. That's not going to work for me. Okay, so I hope everybody's having a good day. Okay, so we're talking about graphing, and now we want to talk about even or odd functions and how that applies, what that means with graphing. So let's start with the even one. So an even function has symmetry over the y-axis. Okay. So an even function has symmetry over the y-axis. And as an example of one of our base graphs, okay, the absolute value of x, which remember is our v. So if we sketch that guy in here, okay, there we go, remember just sketching here. The idea is if you folded it like a book over the y-axis, if you folded it, it falls right down on top of it. Or if you were to flip it that way, either way you flip it, it's always gonna look the same, right? But over the y-axis, not the x, just the y-axis. Okay, so an even function has symmetry over the y-axis. And that's why it fits into the graphing, because it talks about symmetry. So the test for an even function looks like this. One way to do it is to graph it and see if it's an even function, if it has that symmetry. But the algebraic test looks like this. Whoops. If f of x equals f of negative x, then the function is even. So let me give you an example, and this is one that we probably could think about the sketch and what it looks like, but let's just start with like f of x equals x squared plus 3. Okay, so there is our function, and like I said, I know that you could graph this, but let's just think about it right now, not worry about what the graph looks like. In order to do the test, what we need is f of x, which we have, and we need to find f of negative x, which means we need to plug negative x in for regular x. So we're going to say negative x squared plus 3. But when you square that negative x, the negative is going to go away, isn't it? So we end up with just x squared plus 3. Now, do you see how this guy and this guy are the same? So because they're the same, it means that this function, x squared plus 3, is also an even function. It has symmetry across the, or over the y-axis. And again, just thinking sketch-wise, okay, the x squared is our parabola, and 3 is just bumping it up 3 units. So this guy, again, just a sketch, he looks something like that. So just like the absolute value over there, the v, can we close this guy like a book, or can we flip it over and it looks the same? And yes, we can. So there's the visual, but this is the actual math that goes along with it, okay? Alrighty, so let's look at the odd function then. So odd functions have symmetry, I forgot how to spell there for a second, over the origin. Or over the origin doesn't necessarily sound right. We could say about the origin, which sounds a little bit weird as well. But let's have a look at what that means. So odd functions have symmetry, but it's about the origin, or over, or around the origin. So what that means is if we put in a graph here like this. Now again, the hope is that from earlier, we know that this guy is x cubed, okay? But over the origin means that we're going to flip 180 degrees, okay? So we're gonna take the whole graph and we're gonna turn it 180 degrees. And if it looks the same 180 degrees, then it's what we call odd or has symmetry about the origin. So another way to think about that, if this is on your paper right now, just take your paper and turn it upside down. Does the graph look the same? And it should, okay? Turn it upside down, it should look the same. Now look at this guy real quick. If we take this graph and turn him upside down, he's gonna be facing down like this. So this doesn't look the same. So this one is even and has the even symmetry, but it doesn't have the odd symmetry. So different types of symmetry there. So let's look at one here that has, what the test is, I'm sorry. So the test here looks like this. If negative f of x equals f of negative x, then the function is odd. Okay, then the function is odd. All right, so let's see. If I gave you f of x is equal to the cube root of, let's just go with the cube root of x. Trying to figure something out and it's not working. So let's just go with the cube root of x. So in this test, we need two new things. We need negative f of x and f of negative x. So negative f of x would mean just sticking a negative in front of there. So negative f of x is just negative cube root of x. But we also need f of negative x. So f of negative x would look like this. The cube root of negative x. But we might not know what the cube root of the x is, but when you're cube rooting, the negative sticks around and the negative is okay, isn't it? So this guy actually simplifies as negative cube root of x. You can pull the negative out to the front. And so what we end up with is this guy and that guy, they actually look the same. So we're focusing on these two. So we say we have an odd function. So again, one way to do it is just to graph it and look and see, but the other way, the test of it, is that negative f of x equals f of negative x. And just so you are aware, you should expect that somewhere along the line, I am going to ask you to either test for even or odd by using this, meaning I'm going to need to see your work, okay? So even though graphing is certainly one way to do it, just look at it visually, I do want you to practice doing this a couple times. And there are a number of homework problems or practice problems from the book that will help you practice that. Now, sometimes a function has no symmetry. And so if this test were to fail and the even test were to fail, it's perfectly fine for us to have a function that has no symmetry. So no symmetry is definitely okay. Only a couple guys are going to have the even or the odd. And I mean, I can give you an example just real quick here. Again, another one of our base graphs. Okay, that guy is the square root of x, right? Well, if you fold like a book, there's nothing on this side, so it doesn't have any symmetry there because there's nothing over here. And if you rotate it 180 degrees, there would need to be something down here, and there's not. So this guy has no symmetry, okay? And again, like I said, perfectly okay to have no symmetry. All right. Okay, so that was the last part of 1.6, so we're now finished with that even and odd functions. and you should be able to do all of 1.6. All right, I'll see you next for 1.7.